Welcome all. Now I am going to discuss question number 48 from the GATE 2019 paper Electrical Engineering. The question is a 220 volts line 3-phase star connected synchronous motor has a synchronous impedance of 0.25 plus j 2.5 ohms per phase. The motor draws the rated current of 10 amperes at a 0.8 power factor leading. The RMS value of line-to-line internal voltage in volts. You can round off to 2 decimal points. To know the concept of synchronous motor, audience can go through the given NPTEL video link. Let us discuss some useful information to solve the problem. Here, the synchronous motor is connected to the grid. So, it draws the current from the grid, and the synchronous motor has a internal EMF of E bar and a synchronous impedance of ZS. So, the internal voltage can be written as grid voltage minus reactance drop in the synchronous motor. Here, E is the internal EMF of synchronous motor, I is the current drawn by the synchronous motor, ZS is the synchronous impedance of the motor. So, using this information, let us solve the problem. Given data, what it is given? 220 volts, voltage is 220 volts. This is line to line voltage and it is star connected synchronous motor. Also, it is given that synchronous impedance is equal to 0.25 plus j 2.5 ohm per phase. And the motor is drawing 10 amperes current at a power factor of 0.8 leading. So, we need to find out the RMS value of line to line internal voltage. Line to line RMS internal voltage we need to find out. So, synchronous motor is connected to the grid through some impedance. This is E, this is ZS and this is the V. This V is how much? 220 volts. This ZS is 0.25 plus j 2.5 ohms and the current drawn is 10 amperes at a power factor 0.8 leading. So, E is equal to V minus I into ZS. So, this V is line to line voltage only. So, 220 minus the starting current is how much? Motor is drawing 10 amperes at a power factor 0.8 leading. So, 10 at an angle of cos inverse of 0.8 into ZS is 0.25 plus j 2.5 ohm. So, if we simplify this thing, we get E is equal to 141.65 at an angle of minus 8.736 volts per phase. So, we need to find out RMS voltage, right? Line to line is equal to root 3 into E phase. That is equal to root 3 into 141.65. That is 245.345 volts. So, the RMS value of line to line internal voltage is around 245 volts. The RMS value of line to line internal voltage is 245.35 volts. Thank you.